The empirical rule is something that we can apply to distributions that are symmetric and bell-shaped. So when you have a distribution that looks close to this, it's got a nice little bell shape and it's symmetric, we can represent it with a line instead of all these columns, but we can think about how likely it is to be at a certain point in the distribution. So right in the middle is going to be the mean because it's symmetric. And then we could go one standard deviation away from the mean. So the standard deviation of this distribution, if we add one standard deviation to the mean and subtract one standard deviation from the mean, we would end up a set distance away. And then we could do it again. It would be the same distance to go 2 standard deviations away, and then the same distance again would put us 3 standard deviations away. But what you can kind of see is that the number of values or the number of outcomes that fall within each range is not equal. That only 0.1% of observations are more than 3 standard deviations below the mean, but 34% of all observations will fall between the mean and 1 standard deviation away, 1 standard deviation below, and 34% more, 1 standard deviation above, which gives us our empirical rule that if you have a nice symmetric distribution that's bell-shaped like this, then 68% of observations fall within 1 standard deviation of the mean. About 95% will fall within 2 standard deviations of the mean, and about 99.7% will fall within 3 standard deviations of the mean. So this can be kind of weird and esoteric, but let's give it a concrete example, and you can kind of see why the empirical rule can be useful when we know the mean and standard deviation. So this is the distribution of height in an actual data set. So there's a data set you can access online. It's called NHANES, where it's something like 9,000 people were part of a survey where they actually went to their doctor and the doctor took various measurements related to their health. One of them was their height. And so this is real data from real people, and we can calculate the average height, which was 164.5 centimeters, and the standard deviation of the height was 11.03. And so we can take that and we can, without knowing all 9,000 observations, just knowing these 2 numbers, the mean and the standard deviation, we can do a little math. We can take the mean, 164.5, and subtract 11.03, the standard deviation, and that gives us 153.47. And then we can also add the standard deviation to the mean, and that gives us 175.53. The empirical rule is what lets us say, well, that means about 68% of people, so a big majority of people, have a height between 153.47 centimeters and 175.53 centimeters. So this gives us an understanding of, what is a normal height in the population of people. If this sample is representative of the population, then this is a normal height within that population. And then we could go 2 standard deviations away. So now it's 164.5 minus 2 times 11.03. That's 2 standard deviations below the mean and 2 standard deviations above the mean. And now we know where the vast majority of people are. About 95% of people will be between 142.44 centimeters and 186.56 centimeters tall. Notice that our range got bigger. Now this 95% range totally encompasses the 68% range. And of course it does. If we want to include more people, we have to expand our range. But the empirical rule lets us actually determine what that range is. So we can do 3 standard deviations away, and that means about 99.7% of people are between 131.41 centimeters and 197.59 centimeters tall. So the empirical rule can be really powerful with only 2 numbers, 164.5, the mean, and 11.03, the standard deviation. We can actually say a lot about what the population of people might look like based on our data. And that's really powerful and why the empirical rule is so important.